Let me just unplug this. Okay, so we were doing this problem-solving session this afternoon, and these questions ended up being quite difficult for most of us. So I'll try my best to pick questions that aren't quite this difficult in the future. But I didn't want to leave everyone with, not having taken away a bit of information, a bit of thinking from the session. So I'm trying to do a little video here for you to come back to and see how the process works. So the main takeaway that I intended for these questions was that you would see the text and then have enough knowledge to translate the text into maths, into some algebra. And the algebra comes into play when there are things that are not yet defined. So if there's unknowns in the working, then we would use algebra to put some temporary letters in there until we can find out what they're worth. So one technique that I try on word problems is that I will highlight the numbers. Another technique that I use is I try and digest the question one sentence or one phrase at a time. So if there's a sentence and there's a comma, that usually means there's separate information happening around that comma. But here there's no commas being used, so I'm just going to divide it up by the sentence. So just use my brush tool here. So I'm just going to interpret this first sentence and see what I get. So I'm just going to say this is my one, and I'm going to do a little bit of thinking down here is my one. So the denominator of a fraction, so I know I've got a fraction involved, so I'm just putting a little divider sign here. The denominator of the fraction, so this bit here, is 5 more. So 5 more means plus, so I've got 5 plus, or plus 5. The denominator of the fraction is 5 more than the numerator. So they haven't given us any values besides 5 more. So I need to figure out, what are these two values? Well, if I pick a letter of the alphabet, so if I could choose the letter, I'm going to use the letter A. So if the denominator is 5 more, so whatever the numerator is, let's say it's A, so that's my numerator, then the denominator will have to be 5 extra. So that's where I'm at. That's just the first statement there. And then if I go to the next statement here, if 1 is subtracted from the numerator, this is my second sentence, if 1 is subtracted from, if 1 is subtracted means to take away. So if 1 is taken away from the numerator, so my numerator was A, if I take away 1 from it, and then they don't mention anything else has changed, so I'll copy the rest of it as it was. The result fraction is 1/3. Result is another way of saying equals, or it could also mean answer. So if I read that out in English, if 1 is taken away from the numerator, so A take away 1, the result or the answer fraction, the answer is 1/3. So that's how I've translated this into some algebra. So if you're able to do that, I would be very happy. And then assuming this is pitched at the correct, complication. Sorry, if this question was pitched at a year 7 level, then you should be able to do some working from here onwards. But again, this question ends up being a little bit more difficult than I had previously thought. So let's see what to do. So the last sentence, so I'll use green, find the original fraction. So the original fraction here is here in purple. When I say what is the original fraction, they're probably implying here that they want you to find what the actual number is. So I won't know what the number is unless I can find what A is actually worth. So can I figure things out such I can solve for what the letter A is worth? If I can find what A is worth, I can just basically swap them out in this expression, and then I can figure out what the fraction actually is. To find the value of A, I think I have to work with this. This is the other bit of information that's given to me. I have one unknown, and I have one value or one answer. That's usually enough. So if I have 2 unknowns, then I would expect to be given 2 bits of information, 2 bits of values. I could rearrange this or gather like terms and process it and simplify. I could work with this equation until I gathered a on a single side of the equation. So if I can turn this somehow into a equals something, then I could use this and put it into the purple equation and find what the original fraction is worth. So let's do that. I got a choice here. I got two fractions. I don't like when you see a fraction, try and make them isolated. So you try and get rid of the extras that, you know, if there's like a third plus 2, oops. If there's like a third plus 2, then I'll try and get rid of that plus 2, you know, just trying to, but since there isn't any extra terms that's distracting, I've only got fractions, then I've got to deal with the denominator. I want to get rid of them. One way of getting rid of a denominator is multiplying that side. Let me just get my pen the right color. If I can multiply both sides by the denominator, I can cancel it out. So here I've got the same thing, I've just copied it out. But I want to let's say I want to get rid of this 3. I'm choosing the 3 because I think I can deal with 3 times things pretty easily without getting too messed up. So I want to times both sides by the value of 3. So there's my times 3 on both sides. If I do that, then I can cancel out. This basically cancels out that. And this has to multiply into the fraction somehow. So a whole number times by a fraction, that can get people confused. But one thing I can do is I can sort of convert the number 3 into a fraction as well. So the number 3 is the same thing as 3 divided by 1. So that's still the same number. I've just converted the way it looks like so that I can make it work with my maths. So here I can then go 3 times this numerator, and I can do 1 times the denominator. Now, when you have a fraction that has multiple terms on either the top or the bottom, you need to consider that there is an implied brackets around them. So now that I got brackets, I've actually got to start thinking about doing the distribution law, which we've done before. So it'll be 3 times a and 3 times -1. So what am I going to get? 3 times a, well, that gives me 3a. 3 times -1, I'll get -3. And then same thing's going to happen on the denominator. So 1 times a will give me a. 1 times 5, positive 5, will give me positive 5 over here. And then I'm left with whatever remains on this right-hand side. So these 3's have cancelled out, so I'm just left with a number 1. Now I want to cancel out this denominator. Okay, so remember that there's multiple terms on top and bottom, so that you've got to imagine that there's some brackets around them. So I'm just going to put them here, kind of like training wheels. You put them there until you're comfortable with working, to know that, you know, until you're comfortable. So to get rid of this one, just in the same way that I times the same value here, so if there's a 3 down here, I'll times it by 3 to cancel it out. I want to times this whole thing by a plus 5. So I'm going to do, my brush has stopped working. Sorry. Trying to get my stylus to, there we go. A plus 5 multiplied by this right-hand side. I'm going to times this one here also by a plus 5. And just in the same way that we said, well, 1/3 times by 3, well, those two numbers cancel out. So that means that I can also cancel these two things as well. So what am I left with? Well, this is just going to be 3a, take 3. This thing here and this thing here would just cancel out to 1. So 3a to take away 3, all divided by 1. So that 1 is just invisible now because it's not needed. 1 times a gives me a. 1 times 5, positive 5 gives me positive 5. Now I can start solving it to make a all by itself. So you can do sad mob, which is the opposite of BOMDAS. So you undo anything that's added or taken away. So I can undo this subtraction here. So if I add 3 to both sides, See what I get? So I get 3a. Negative 3 and positive 3, they cancel out, so they disappear to 0. So 3a plus 0, that's just 3a. A plus 5 plus 3, so 5 and 3 together gives me 8, so a plus 8. Now I've got a's on both sides. I want to get rid of this one over here. So I'm going to, instead of having a positive a over here, I can do a negative a over here and a negative a over here. So what do I get? 3a, take away a, I'm going to have 2a left. Positive a and take away a, I'm just going to get 0. So 0 plus 8, that just gives me 8. Now I'm going to try and get rid of this 2. And there's actually a little multiplication sign that's implied between these two. So to do the opposite of times, I must divide. So I'm going to divide both sides by 2. And so 2 divided by 2 gives me 1, so 1a, so just a. 8 divided by 2 gives me 4. So now I've found the value of a, it's just 4. Returning to the original question, something that I like to do is once I've sort of arrived at a number or arrived at an answer, I always like to sort of go back to the original text and read it once more, because sometimes you sort of lose the plot, you lose what you're trying to do with it all when you're doing a long solve. So I like to come back and just remind myself the denominator of the fraction is this. If 1 subtracted, it's third. Find the original fraction. Have I found the original fraction? No, I haven't. I just found that the letter A is 4. So what have I got to do with it? Well, now I can actually stick it into here. So I can go substitute A equals 4 into 1. So what am I going to get? I will get 4 is all divided by A plus 5. So that gives me 4 plus 5. So that just gives me 4 over 9. So now I have finally solved the answer. So the original question is 4/9. Done. So that's the first question. The second question, which was a lot easier. Here we can see there's like I mentioned before, that I like to cut it up into sentences or phrases. So here I've got a phrase. So Rodney guessed the total. See the comma there? So if I cut it off at the comma, so Rodney guessed the total was 34.71. And then I got a second sentence here, but this was 8.9 times the total. And they want you to find out what the actual total was. So I can start translating this piece by piece into maths. So I've got Rodney guessed, so like I don't really need that. So Rodney guessed the total. Total was 34.71, but this, so what's this mean? Well, this means that number. So this usually refers to a previous statement or a previous number that they just mentioned. So it says this was can mean equal. So this was equal to, let me just reassemble. So 34.71 was means equal sign, so equal 8.9, so equal to 8.9 times, well, that just means multiplication, times by the total. So again, if you're able to take that sentence there and translate it into this maths, then I will be very happy. But since this one is pretty small and simple, we could then basically start working on it to find out what the total actually was. So here's the total. I just want to make the total, I want to make this the subject, meaning that it's all by itself on one side of the equation. So that means I need to get rid of this 8.9 times. So what's the opposite of times in something by 8.9? It's going to be divide both sides by 8.9. And I'm not really able to do this division thing on paper very well, so I'm going to use a calculator. And so if I've done using the calculator before, you found that this left-hand side works out to be 3.9. And what's 8.9 times and then divided by 8.9? That just cancels out to 1. So 1 times the total, that's just total. Okay, and so that question is done. Moving to the last question, which was a lot more tricky than I had hoped it would be. Again, if you could just take the text and translate it into maths, I'll be very happy. So let's try that trick where I mentioned we go a sentence or a phrase at a time, and then sort of translate the English into maths one bit at a time. So I can see a comma put over here, so I can put little, I can sort of cut it up into pieces. So there's another comma over here, so it's cut off from there. So I've got this section here. This is a phrase. And then I've got this section here is some more information. Then I've got this section here is another bit of information, and so on. Let's go bit by bit. So the green bits, I'm just going to put 1. If 3 is subtracted from the numerator, so subtracted means a takeaway sign. So if 3 is taken from the numerator, so if I take money from you, that's going to be less money for you. So they don't tell me what the numerator is, so I'll just put, maybe I can just write the word numerator. I mean, you could use a letter, but I'm just going to use English for now. Numerator has lost 3 of a fraction, so that means there's something down here. So I don't know, did they tell me about it? No, they don't tell me what it is, so I'll just erase that and put denominator. Okay, so that's the first bit. Second sentence they give me, they say that the value, so value is like number, so that means I'm just going to use a hashtag sign as a way of sort of telling you the number. So the number of the result, as we sort of talked about before, result is another way of saying answer or equal sign. So the number of the answer is a half. So they're saying that whatever this was, they're saying it's equal to a half. Okay. For the green bit, I'm just going to swap them out for letters just to make, because if I have to write this over and over again when I'm doing some maths, I'd rather write with less effort. So I'm going to use A for the numerator, and I'm going to use B for the denominator. Okay, so basically I'm going to have this thing here is equal to a half. That's what we've given so far. Let's look at the computer. Come on, don't fail me now. All right, it's back. So now we're up to the pink statement. This is statement 3. If 13 is added to the denominator, okay, of the original fraction, so here's my original fraction, A take 3, and there's the B. They're saying if 13 is added, well, added means plus, doesn't it? So 13 plus the denominator, so here's my 13. The last sentence here, which I haven't highlighted, says the value of the new fraction, so the number of the new fraction, so this is a new fraction, is another way of saying equal sign. So the value, the number of the new fraction equals a third. So the value of this new fraction is equal to a third. And they want us to find the value of the original fraction, which will be the green one, the first statement they gave me. So what am I going to do with this? I can clean this up a little bit and summarize what I've been given. I've been given 2 equations. So I'm going to use blue for the first one. So I've been given this equation here, A take 3 over B is equal to 1/2. I've also been given the second one here, which is A take 3 divided by B plus 13 is equal to 1/3. And if I scroll to the earlier problem we solved we have this one here, we had one unknown, which is that letter A, and we are given one value, which is actually a number. Okay. This is solvable. For every unknown, I should hope to have at least one value or some information that I can work with. And the computer stopped working. Come on, come back to me. Right. Here, I have two unknowns. So you can see we got the letter A and we got the letter B. These are two unknowns, but I'm given one value over here, and I'm also given one value over here. So I should be able to work things out to find what each of those unknowns value is. I don't know I have enough space here, so I may need to start a new page. Let me just see if I can do Control Shift A. No. Oh, did that work? Just trying to do the Mac shortcut on a Windows computer. So let me just put all this away, group that and hide it, and then I can take this entire layer and just push it out the way. Problem solved. And then just keep marching on. Okay, so I've got the blue and I've got the pink. I've got two unknowns, but I've been given two values, so I should be able to solve this. So my strategy here, and I'm sure that people who are watching this video, you can probably see another way of doing this. So one strategy might be to try and make this number and this number the same. So can I multiply both sides of this equation to make this fraction, and multiply these two sides of the equation by something to make this fraction the same thing? Then I could sort of see if I can cancel things out. I'm not going to do that because I think that'll be confusing. I think either way I try this problem, it's going to look confusing to people. So I'm just going to try my best to communicate what I'm doing. So one thing I'm thinking of instead is that what if I sort of rearrange? So that's my particular cartoon symbol. It basically rearranges. That's what the symbol I use there. So if I could make A the subject, so everything else, including that B, is somewhere over here. And then if I take this one here in pink and rearrange that such that B is the subject and everything else is equal, then I should be able to put this number into here, and then I can find what the A is worth. And same thing, I could take that A, stick it into here, and find out what B is worth. I know that looks confusing, and it kind of is. It's usually quite an advanced thing that I wouldn't expect Year 7s to do. So if you're unable to follow me from here onwards, I totally understand, because this is relatively difficult. So I'm just going to do the best I can at explaining how I'm doing it. So my goal here is to try and make A all by himself. So let's see if we can do that. If I want A all by himself, I want to get rid of the B. So to get rid of that B, I'm going to times both sides by B. If I do that, then the B's will cancel. So it'll just be the numerator divided by 1. So that just becomes the numerator all by itself. So I'm now left with A take away 3 equals 1/2 times by B. Now in maths, you don't want to use the times symbol if you can avoid it. So I just put half B. And you could do the maths if you want to. So that there is the same thing as B on 2. Because if you think about it, B is the same thing as B over 1. And if they're times to each other, then I just get B on the top. I got 2 times 1 on the bottom, so I just get B over 2. I'll just copy this down so you can see where I'm at. Now I want to get rid of the 3. So to get rid of that 3, I'll add 3 to both sides, because -3 plus 3, they cancel out to 0. A plus 0 is just A. I've got to do plus 3 to both sides, so I'm going to hit my plus 3 over here. So I'll get B over 2 plus 3. So now I have a whoops, wrong color. Now I have a equation where A is the subject, and I could then stick this I could stick this into this pink equation. So if I put this every time the letter A shows up, I should be able to find an answer. So let's try that. So I'm going to substitute that as best as I'm able to, clearly as I can. I'll keep the colors consistently. So A is now going to be swapped out for the B divided by 2 plus 3, because that's what A is worth, isn't it? So I'm just going to put this whenever the letter A shows up. So I'm going to get B over 2 plus 3, because that's where it appears up here. And then I'm copying out the rest of the pink as it was. Let's see where we can go from here. Well, plus 3 and take away 3, that just cancels, doesn't it? So I'm now going to have B over 2 now what I'm going to do, I'm getting closer, so we're simplifying, we're cancelling out, we're gathering terms. Where can I go now? Well, I could get rid of this 3 by multiplying both sides by 3. So let's see if that helps me. So I'm going to times this by 3, and then times this by 3. And the same trick we had before, where this will be easier if I just sort of turn this into a fraction and turn that into a fraction. And these 3's will cancel out. So I will get 3 times this up here. So I'll get 3 times B on 2 all over B plus 13 equals 1, because there's 3's cancelled over here. Now, if I want to cancel out this denominator here, I want to multiply both sides by this. Remember, there's little brackets around here. So I want to multiply by that thing. I'm out of space over here, so I'm just going to write it down. B plus 13. And then let's see, well, this will cancel out that. So now I'm just left with this divided by 1. So that gives me 3 times B on 2 is equal to 1 times this, which just gives me, because like 1 times that gives me B, 1 times positive 13 gives me positive 13. We're getting close. Let's see if I can get rid, what can I do? Well, if I do this, I can work with this. So 3 on 1, so 3b over 1 times 2, which is 2. What can I do now? Well, I can get rid of this 2 by multiplying both sides by 2. So those 2 will cancel out, so I'm just left with 3b. And then I got to do distribution law. So 2 times b will give me 2b. 2 times 13, 2 times positive 13, sorry, I will get 26. Very close now. I want to get rid of 2b from both sides. So if I subtract 2b, that will cancel out to 0. So that becomes nothing. Nothing plus 26 is just 26. 3b, take away 2b, that's just gives me 1b left, which is awesome. So the answer here, I've actually got a real value. So I've got one of them. Now I just got to figure out what A actually is. So my pen has stopped working again. If I take this and substitute it back into here, so every time the B shows up, I could just swap out the letter B for the number 26 and see what I get for the letter A. So A is equal to, remember swapping the B for 26, 26 on 2 plus 3. Well, we know that 26 divided by 2, well, that's just half. So that gives me 13 plus 3. I can gather that together and I get 16. So A is 16. So now from those two equations, two bits of information, I could find my two unknowns. Now the unknowns are defined. I know what they are now. Let's go back. It's asking us find the original equation, which was this. So let me copy that down. A take 3 over B. So equation. Sorry, the original, not an equation, fraction. Was A take away 3 all divided by B. We know that the letter A is 16. So 16 take away 3 all divided by, and we know the letter B is 26. So I just put them in. Now what do I get? Well, 16 take away 3, that gives me 13 over 26. Well, can I simplify this? Well, I can divide this by 13 and divide this by 13. And that gives me 13 divided by 13 is just 1. 26 divided by 13 is 2. So I get the answer is a half. Done. And if you really want to tie it off, you can say the original fraction is 1/2. So I can see how that's a really big question if we zoom out for a bit there, but hopefully you can sort of see how I pieced it together. The takeaway is that if you can turn the English into maths, that's the goal that I had hoped that we would walk away from. They're not easy to do. There's some implied knowledge happening here where you have to try and take the English and then see what their maths equivalent is. So whenever you see the word value, you have to think of a number. Adding is obviously a plus. Subtracting is always a minus sign. Result can mean equals, or it can mean answer. When you see the word is, that can also mean equals. And when we looked at our previous working here, where was it? I think it was down here. Was can mean the sign equals, and this usually refers to what came previously. So I hope that from this you're able to pick up some of the tricks that I use to try and translate, and hopefully even just watching me problem solve the maths and doing, working through the algebra, hopefully you can sort of see how clarify how to do them. That's it for the video, guys. Please let me know if that helped. I spent a little bit of extra time this afternoon to make sure you had something to work with when you get home. Thank you, guys. Bye.